So this is our test review for page 69 through 78. You see most of it's kind of grouped into 70 to 75, along with a few other problems that we'd worked on. This is our period 1 presentations.
Alright, so this is page 70, number 1. An atom of carbon-14 is unstable, meaning that it can spontaneously transform itself by radioactive decay into nitrogen at any instant. The probability that this will actually happen to a specific atom of carbon-14 in the course of a year is only 0.0121%. However, in other words, there is a 99.9879% chance that any specific atom of carbon-14 will survive another year. Suppose that 1 million carbon-14 atoms are placed in a container. How many of these atoms are expected to be carbon-14 atoms 1 year later? The half-life question. How much time will it take for half the atoms to decay? So I kind of did this opposite. Oh, that was cool. So this is the first question of this one. So it keeps 99.9879% of the atoms. So you start out with 1 million, and then this is your growth rate. It's only dropping by 0.012%, and then this is your 1 year, and so you get 999,879 atoms 1 year later. Pretty straightforward. Now for the how much time will it take for half the atoms to decay? You put your oh, I'd already written that up there, so don't worry about that. You do your exponential equation, where this is the starting and this is the decay rate, and this is your years, and you want to end up with half of the atoms, so 500,000. Then you just divide a million from both sides, so we get 0.99879 up to the n equals 0.5, and then you can rearrange that into a logarithm where 0.999879 is the base and 0.5 is the not base, and that equals n, and you just calculator it, and you get 5,728 years.
Calculator.
Thank you.
Thanks.
All right.
Took a while.
Okay, so this is page 74, number 4a. So you want to find the sum of the geometric series of 3,000, and then it goes all the way to 3,000 times 1.05 to the 20th. So we know that the multiplier is 1.05, and on this top box right here, Colton accidentally wrote 1.5, but that's wrong. So pretty much what he did is he has the sum, the sigma right here, and our equation is in the sigma of the, what you're going to multiply it by, and n equals 1, because that's your starting one, and right there, and then it goes all the way up to 20 because of 1 and 20. But it's n minus 1 because you don't multiply that by anything, so it would be to the 0th. And I don't know this other one, so Colton can explain it.
Which one?
That one.
That's just the same thing without the n minus 1. I'm pretty sure that works also, so I just put an or.
What about on the other side?
Yeah, what about on the other side?
Okay. That's just, that was like, if you want to use your calculator, I think this is the other way. So I put the yeah, I just plugged in this right here, and then did the max, or the oh yeah, added 1, so the 21 plus 1, because that's what you do, and then subtract, this just equals 3,000, because this is the 0th, so, and then over the multiplier, subtract 1, and I'm pretty sure that's it.
Okay, your work looks very nice. I'm not sure how correct it is. So let me do some correction here. Let's see. I like your multiplier here. Joe's right. That should be 1.05. Okay, but that's not a big deal. We could go get through that. I'm going to use this bottom equation. I just think it's easier without the n minus 1 here. So if I substitute a 0 in, I do get 3,000, so that's good. But on the last one, it says a 20th power. So I don't need a 21 right there, because these are the numbers that you're going to plug into your equation. And since I have an n right there, the last one should be 20. So this should actually be the 20th power. Okay, I'm not going to worry about this one. I could fix that, but I just want to make sure I have one of them that's nice. So this one works out well. Now we go over here. The equation is set up pretty well. Okay, this is always the number, or sorry, this is always our formula. This exponent should be the number of terms. Okay, how many terms would be in this? 21, because you start with a 0. This is a 0 power. We said that right here. It's a 0. 0 power. So this should actually be a 21. This is always our first term. So that looks good, because our first term was the 0. And then whatever's in parentheses minus the 1. Did anybody have an actual answer for this one? What was it?
107,157.75.
I'm trusting Mason there. Use his calculator correctly. And that's what he got.
So we had number 4, find the sums of the following geometric series, B. And so what we did is we just plugged it into kind of that exponential equation where the first term was this 18, last term this. So we plugged it in 18 times negative 2/3 to the 50th, because there are 50 terms, minus 18 times negative 2/3 to the 0 power, divided by negative 2/3 minus 1, and then we got 10.8 as our answer.
Okay, so all we're doing here is using sigma notation and then plugging that into the equation. So it says 12 times 3/5 to the k, and it starts at 0 and it goes to 9. So we take 12 times 3/5 times, or to the 10th power, because you add 1 to find the number of digits. And then you subtract 12 times 3/5 to the 0. And then divide by negative 2/5, because that's 1 minus 3/5, or 3/5 minus 1, sorry.
Okay, so in F, we were supposed to express this series as in sigma notation. So we first found the equation to be 8 times 1/2 to the n power. And then we put that into sigma notation. And we got that 1/8 was the 6th term. So we got that, and then it starts at the 0 term. And then we got the answer to be 15.875.
The rebound ratio of a speckled green Super Ball is 75%. It is dropped from a height of 16 feet. Consider the instant when the ball strikes the ground for the 50th time. And then A, because we have question A, is how far downward has the ball traveled at this instant? So our group, we did some math here. We used our standard formula that we typically would use. So we used, because it's a 75% rebound ratio, we took your starting amount of 16 and multiplied it by 0.75, which represents the 75% rebound ratio. And then we put it up to the power of n minus 1, and your n would be 50, so 50 minus 1. And you'd subtract it by 16 again, and then you divide it by the parentheses minus 1. So that's how you get the negative 0.25. And you go on. This just shows more of the maths and the steps. And this is the next step. And then we got a final answer of 63.999, or about 64 feet total downward traveling distance.
Thank you. Now be a little bit careful here. And why I'm saying that is because if I look at this right here, how many terms would there be right here? 50, which means you wouldn't have 50 minus 1 right here. You just have 50.
Oh, would 16 be term number 1 technically?
Because 16 would be the first term.
And not a 0 term?
Well, that would be the 0 term. But since that would be the 0 term, where you start right here, that's fine. But there are 50 terms. So this should be a 50. This is correct because you go from 0 to 49. Now, it didn't make a huge difference because whether it's the 49th bounce or the 50th bounce or the 51st, it's a really, really small difference. So it's not going to make a huge difference. Your answer is close enough because that 50th thing is not going to matter. Okay, this is number 6. B, the rebound ratio of a speckled green super ball is 75%. It is dropped from a height of 16 feet. Consider the instant when the ball strikes the ground for the 50th time. So what this group did is they were using the equation 16 times 0.75 to the 50th to represent the 50th time it travels downward. So imagine their super ball is bouncing like this. And so on. So at this point right here, it's dropped. And that's 16 feet. And that's for the first, and so on. So this group did is they used their geometric series formula twice. The first one is for the downward, because we start at 16 feet here. And then do the 50th power, because that's the 50th bounce, minus the first one, divided by the parentheses minus 1. That gives you 64 feet for the downward, plus they did the upward. Well, there's no 16 on the upward, so they wrote a whole new equation here. Upward, first upward's 12, and then 9, and so on, and they did the same thing for that. They added the two together. The downwards are 64 feet total, the upwards are 48 feet, for a total of 112. Okay, this is for Jacob's group. In order that the sequence 9, x, 16, of positive numbers be geometric, what must x be? This value x is called the geometric mean. So we know the first term is 9, the second term is x, the third term is 16. You have to multiply by the same number each time to get there. So we call that number they multiply b. So now they know that 9 times b equals 16. 9b squared equals 16. Square root, or divide by 9, then square root it, end up with b is 4/3. So what they did is 9 times 4/3 to the n minus 1 power, and they solved it for 2 to get 12. Quick way for geometric mean is you would take the square root of 9 times 16. Shortcut, square root 144, which is 12. So the geometric mean of A and B would be the square root of A times B.